And welcome to everybody here. I know at the moment there's been a lot of webinars going on in this COVID-19 lockdown time period, and I'm sure a lot of you don't know which ones to look at and which ones not to look at and which to attend. Tonight's one I'm hoping you're going to find very interesting. I have presented this exact same one before, and tonight is a rebroadcast because of so many people asking us to redo it because they wanted to see it or they missed it and so forth. Why we are doing this is that we're finding that a lot of people are changing geyser valves, specifically the pressure control valve, unnecessarily. You get there, the customer has complained that the valve is leaking. You go, you replace the valve. Later the day, 2 days later, the customer phones you and says, no, it's doing the same again. And you go and you replace the valve again and again. And we don't actually get behind the problem. So tonight we want to have a look at what the problems can be and so forth. So that is what we're going to do tonight. We're going to first have a look and see how the valve works. Now, you'll notice that I am from Cal Africa, and this presentation is brought to you by Cal Africa, but the information is not generic only to our valves. When I describe how the valve works, all that type of thing, it is generic. Most of your valves, or all of your valves, actually work exactly the same. The way it's achieved may be a little bit different, but the principle behind it is exactly the same. The next one we'll just very briefly have a look at is what is balanced pressure, and why did unbalanced pressure previously not have as much of an impact as it does today. Then we'll have a look at the fault finding and the recommissioning of the valves. Okay, so your operating principle is that you have got this valve. When you get it, it's in the open position because that spring that you see at the top is keeping the valve open all the time. So it is normally open. As the water starts going through it, you will have a bit of water going through this little hole in the top on your cartridge, and that takes water to underneath the diaphragm. Let me just quickly put my pen on, then I can show you guys here. Okay, there we go. So that hole over there, in this case, is the bypass. So that takes a bit of the water from this main supply of water, and it takes it and puts it in underneath the diaphragm there. As the pressure builds up underneath the diaphragm, it then compresses the spring and allows this main seat to close. So if we just have a look at that quickly, there it is. Your water is pushed in underneath the diaphragm. You see the diaphragm has compressed the spring and the main seat is closed because now there's no movement of water. So this is where you've commissioned the water, all the taps are closed, and the valve has come to rest at its normal set pressure. Then when you open the tap, you will see that the pressure is relieved underneath the diaphragm there, and this spindle section is moved down, and it allows water then to flow through that area and to your taps. Once you shut the tap, we will go back to the previous drawing scenario where the water will push underneath the diaphragm and close off at the set pressure. And as you can see, it's very simple. It depends on which valve you use as how they attain it, but otherwise the principle, as I say, works exactly the same. Then if we have a look at balanced water pressure, I've heard some weird comments as to, you ask a plumber, is the system balanced? Has it got balanced water pressure? And he'll say to you, yes, it is balanced water pressure. The two vacuum breakers at the same height. Okay, now the vacuum breakers do not give you balanced water pressure. The position of your pressure control valve gives you whether it's balanced water pressure or not. So to get balanced water pressure, you need to have the valve in such a position in the system that your hot and your cold is at the same pressure. So here we can see the hot is at 400 and the cold is at 400, and then you working in on the delivery point. Now, this is where the big problem comes in. If you start having an unbalanced pressure scenario, these days our taps are all got flow restrictors in them, because you'll know that we are now being limited to 6 liters per minute flow on a basin, 9 liters per minute flow in a shower. So the amount of water that can come out of this point is regulated. Now, if I've got an unbalanced pressure installation, the cold is pushing much harder than the hot. Only so much water can go out here because it's flow restricted. So what then happens is this extra pressure is pushing the hot water back, and it then pushes the water back into the geyser, and all this nice stuff that's lying in the bottom of your old geyser gets brought up into suspension and gets dumped into the inside of the valve. And you'll open the valve and you'll wonder, now, how did this dirt get on the wrong side of the strainer? Because where the water comes into any of your valves, there's normally a little wire strainer which stops any particles from coming through. And if you look on the downstream side of that and you see dirt, how did it get through those little meshes? Only way is it's come from the wrong side. It's brought this water from the wrong side of the valve and dumped it on the main seat. So if we open a valve and we see that dirt in there, you immediately know it's an unbalanced pressure installation without even checking the pressure. So there we go. The valve then must be on the downstream before any hot and cold lines tee off. So your hot and your cold water pressure will be exactly the same. Statically, obviously, and that's a discussion for another night, where we will have a look at dynamic or flow pressure, and that we must balance to a certain extent also. But tonight we're just going to be talking about static pressure, balancing of the system there. So then, how do we test for balanced water pressure? Can I test for balanced water pressure at a garden tap? No, I can't. Why? Because your garden tap is normally taken off on the area before the pressure control valve, because SANS recommends that any high flow areas, like your garden taps, flush valves, that type of thing, be taken off before the pressure control valve. So, no, I cannot test it from a garden tap. It is only going to give me what my mains pressure is normally, not what my set pressure on the valve is. So I need to go to a point where there is a mixing taking place. So can I go to a single lever mixer? Yes, there's mixing taking place. The only problem being is most of our gauge sets do not have the correct thread adapter to change that outlet there to a 1/2 inch or 3/4, which is what all our gauge sets are. So that on this case now is a M22/1 or M24/1, and we don't have an adapter to go there. So what do we do now? We've got a mixing point, but we cannot use it. An ideal mixing point would be your shower. So you can take the shower rose off, that's the standard 1/2 inch BSP, and all your shower roses. I haven't seen a single one that is not 1/2 inch BSP. So there you can screw it on there, and now you can check for hot and cold. And see then if that pressure is the same. So now we get there to site, and how are we going to find the problem? Well, it's normally going to be due to a process of elimination. We get there first and we say, okay, what is the problem? Normally you'll know the customer has either called you because the valve is leaking or whatever it is. So we know what the symptom is. There's water, excessive water coming out of the overflow. Why is it coming out of there? So what is causing this symptom? Is it the valve that is faulty? Is it an installation that's wrong? Is it unbalanced pressure? So if we have now ascertained that yes, the product has failed, we need to try and ascertain as to why it failed. Is it a product failure in the manufacturing? Has it got a pinhole in it? Has it got some wire drawing? Is there an O-ring that's missing inside? A diaphragm that's torn? Anything like that? Or did it fail because of fair wear and tear? And one question we need to often ask when we get to site and there's a faulty valve or a so-called faulty valve is to check and see if anything has actually changed in the system recently. Ask them, when last did another plumber work on the installation? I've had it where you get there, no, this valve is faulty. And then you find out somebody has made a change, changed a tap from one type of tap to another, and now all of a sudden the unbalanced pressure is exacerbated and it's making the back pressure worse. So sometimes we've got to do almost like a little bit of a forensic study to go and have a look and see what's been happening on the site before we can actually decide, is it the product that's failed or is it the installation? Just as a very quick little, let me just get this going again. There, just as a quick testing procedure, when you get to site first, the first thing you do is you leave all your tools in the car. All you need to do is turn off the power supply to the hot water cylinder. Because if it is expansion, it's expanding because the geyser is heating. The geyser is heating because there's electricity that's connected to the element and it is causing it to heat up. So if we turn off the power supply to the hot water cylinder, it should immediately stop dripping. If it stops dripping because now we've switched it off, we know the valve isn't faulty because it's doing its work. It's actually getting rid of extra expansion taking place. But now the people say to you, but it never stops dripping. It's always dripping. Surely it should stop from time to time. Then you may need to have a look and see what the temperature of the water is. It could be that the thermostat is never switching off and that it's just continuously heating up and always expanding. If you also have a look and see if the water meter is not moving while expansion is taking place, then you know it's from nothing else because there's no more water coming in. It's just the expansion happening there. So now, if it didn't stop dripping, we know it's not expansion. Now we must have a look and see why it hasn't stopped dripping. Is it because there's an unbalanced pressure on it? All that type of thing. Is there an alternative feed coming in from somewhere? The quickest way to check and see if there's an alternative feed coming in is if there is an isolating valve, a stopcock or borecock, anything like that, just before the pressure control valve, is turn the water off there. If when you turn that water off, all of a sudden the geyser stops or the valve stops dripping, we know it's a valve that's faulty. Because now that we've stopped the water supply to it, it now stops. So now I know it's the main seat or the relief seat that's not shutting off. If it does not stop dripping, where is this water coming from? Then we know that this water is an alternative supply from somewhere else that's working in on the system and causing it to drip. Then we're going to have to see where else there's another feed to the house, and we need to isolate that and to see if that then stops the whole system from working. Now we've ascertained that maybe it is just expansion, and the customer says, but it never stops. How much should the geyser drip? And yeah, you can write this formula down and you're going to look very clever to your customer, and it's quite accurate. If you have a look, it's H minus C times L times 0.0004. Now what does this actually mean? H minus C is how cold was the water when it came in, and how hot did we make it? So it's the difference in temperature times by L, which is how much water I heated. And note, this isn't the size of the geyser. This is how much water was heated. So if I'm measuring it over a 24-hour time period, I've got to try and determine how much water was heated in that time period. It could be a 200-liter geyser, but I've only heated 100 of that water. Or it could be a 100-litre geyser and I've heated it twice. It could be 200-litre. So I've got to try and check and see how much water has actually been heated. Then 0.0004, that is a constant. That is the expansion coefficient of water. So if I take 1 litre of water and I heat it by 1 degree Celsius, I'm going to get 0.0004 litres of expansion. And that's simple. That's the law of nature. It cannot change. That's why I say it is fairly accurate. The only unknown here is to know exactly how many litres of water the customer heated up. But we'll need to determine that more or less. So in my example here, if I heated the water to 65, which is where most of our geysers are set, and it came in, say, at 10 degrees, it's a bit wintry now, so it's coming in fairly cool, and I heated 175 litres of water, then I'm going to get 3.85 litres of expansion. So if the customer puts a bucket there or some measuring container and he can see exactly how much water dripped, then he can measure it. Don't have a look and see, oh, but this paving is sopping wet. Because if you take a cup of water and you pour it out on a cement slab, you'll be surprised on how big a puddle or how big a wet patch a cup of water, 200 mils of water makes. Here we're doing 3.85 litres of water. It's going to make quite a damp patch. And if it has done this continuously, it could be going mossy already. So we cannot just work on the symptoms that we see there, that there's a big patch of water and there's mossy and all that type of thing. We need to actually check it. So now, if we just have a look at this little chart, we're getting to site to have a look and see why the valve is leaking. And that's what we get there for. That's the complaint. So yes, it is leaking. Now we need to get our gauge set. So this is the first tool that you're now taking out of your van, your vehicle, and you've got to go and test it to make sure what the set pressure is. If the set pressure is correct, so the valve is shutting off at the right time period, but the expansion valve is still dripping, we know that the expansion valve is faulty. So then we need to go and have a look at that. So let me just switch my pen off, otherwise this isn't going to work. No, it still doesn't want to work. Okay, don't know why it doesn't want to work, but let's just go and go to the slide here. Okay, so there is the slide that it's supposed to jump to. That is our expansion valve, and you'll see that a lot of the expansion valves on the market these days has got this little easing gear on it. You can click it. And the reason for that is in case any lime scale or dirt or anything has got stuck underneath that seat, we can then just click it, flush it out, and quite often that solves the problem. So if we've now gone to it, we've clicked it a couple of times, we've flushed a bit of water out of it, and it has now stopped leaking, then we know we're okay. So now it stopped leaking and we're good. If the main seat or the set pressure is not correct, so the valve doesn't stop, it just, when you put the mains pressure on, it just goes straight to relief, not to set pressure, then we've got to have a look at your main seat area. And that is that section. Let me just put the pen back on again. So that is this section at the bottom here where your water will get stopped. So no water will carry on past there when it's in the closed position. So that's the main seat. So that's where you need to go and have a look for dirt. You also need to have a look at your bypass, that one over there, because if it's got dirt stuck in it and it cannot put water in underneath the diaphragm, you're never going to get pressure under the diaphragm to compress that spring and allow the valve to close off. So those are your two main areas that you've got to have a look at to make sure that your main seat is clean and that your bypass is open. So take a little paper clip or something like that, a thin piece of wire, and just push it through there. Lift your diaphragm up over here, turn it up a little bit, and make sure that your wire is coming through neatly and there's no dirt underneath there. Once that is done, you should then check and see that your main seat is now shutting off and you are getting to have a proper working valve. And there, we'll have success. Okay, so now we've tested the valve. The first thing we're checking is to see if the set pressure is correct. If the set pressure is correct, then it must be the relief valve. If it's not stopping, it's going straight to the relief, then we know it must be the main seat that's faulty. Okay, so let's have a look. The next one we have a look at, there's a typical valve that's now installed. And as I said, the first thing that you need there is a gauge set. And like you can see on this one, it's got a 15 or a half-inch BSP and a 3/4 BSP adapter on there, so that you can then go to any half or 3/4 and test it. Once again, can we test it a single tap? It depends where that tap is. If it's a garden tap, no, you can't. But it could be downstream. It could be in the laundry in the house where you've got balanced water pressure and hot and cold. It just means you're going to have to change from one tap to the other when you're trying to test. So it's easier to test it at a mixing point. But yes, as long as your testing point is downstream from the valve, you can test from there. Now we've been talking about set pressures, relief pressures. What must that pressure be? Now I've taken my gauge, I've seen some readings, but how do I know that the readings are correct? Well, there's a standard chart from SANS 198 which gives you all the set pressures and the relief pressures. And you can see that each pressure rating has got a color, and I'm sure you're all familiar with the different colors. 100 kPa being blue, 200 kPa being black, 300 brown, 400 red, 600 green. Now, how am I going to remember all these settings? Because surely, I can't remember all these things. So what are we going to do? All we need to do is have a look at your 100 kPa one. Because these settings is a percentage or a ratio of the complete. So 70% of 300 kPa is 210. 85% of 300 kPa is 255. The same again with 400 kPa. 70% of 400 is 280. So the only one we need to remember is this very first one, the 100 kPa. And from there you can see what the set pressures on your valve must be. Now when we say set pressure, obviously as you can see, when I first install the valve, I'm not going to get 100 kPa out of a 100 kPa valve. If I've got my gauge on there, it's only going to be between 70 and 85% of the pressure rating. So on a 400 kPa, your set pressure is between 280 and 340 kPa. So don't be alarmed when you get to the valve and you now check and say, oh, but this valve is not giving me the correct pressure. It's rated at system pressure, which is the same as your relief pressure. We see there the maximum pressure that it will relieve at is at 400 kPa, so that would then be a 400 kPa valve. So when we've now done all our valve, we've stripped it, we've cleaned it, we've put it back together again, we now need to commission the valve, and that's where our gauge comes in again. So we need to connect it, make sure the electricity to the geyser is off, turn the water back onto the system, and you must make sure that that pressure is what you are going to be getting. Now some valves you can actually set the pressure. The Kalefi valve, there is a little screw on it, and I'll just go back one slide here. Underneath this cover over there, if you pop it off, it's just siliconed on. You'll see there's a set screw, and you can actually adjust the pressure there. So if you find that maybe a 400 kPa valve is only giving you 250 kPa once you've recommissioned it, then you can actually adjust it up, and we normally set a 400 kPa valve to about 300. That's slap bang in the middle there. Okay, so that's where we like it to be, a 400 kPa giving you about 300 kPa, and then your relief pressure. How are we going to test the relief pressure? Well, here we're going to need to turn the geyser back on again now so that it starts heating up the water, and you'll see very soon, within a couple of minutes, you'll see the pressure starts climbing, and then you'll see the gauge stop at a pressure reading, normally around about 390 to 400 kPa. And I can guarantee you, when you go outside and you have a look at the end of the pipe that comes from the relief, it's going to start dripping. Then you know your valve is working 100% and you've commissioned it properly. It has now been brought back to the manufacturer's standard specifications and set pressures. So that is important too. Not just knowing how the valve works, but how to bring it back to the manufacturer's specification, and also to make it comply to SANS 198. Because if it doesn't comply to SANS 198, we cannot do a COC on that geyser installation, because 10254 says that the whole system must be compliant to 198. So you see how important it is to understand exactly how this valve works and to check the system. We can't just change a valve and give a COC and say, there you go, because we haven't checked to make sure that we are actually compliant. We may not have brought it back to SABS specification when we change that valve. That, ladies and gentlemen, brings me to the end of what I've got to say to you. And you will see on your screen, my contact details are coming up. And I did mention it to Karim earlier. There is no handout tonight because I didn't know if people really wanted it or not, or needed it. But if any of you want a copy of this presentation, please just drop me a mail and I will gladly send you a PDF version of this presentation. So you can either phone me for questions, there my number is there, or just drop me a mail or WhatsApp or whatever to request a copy or information if you want.